This problem asks to draw a stepwise mechanism for the given reaction. Before I write the mechanism, let's see what are the reactants. So this is a reaction between cyclohexane and hydrogen chloride, and it gives the product cyclohexane. So this is a alkene. So therefore, if you see the product, the hydrogen chloride has added to the alkene. Therefore, this is an addition reaction. And what is the mechanism of this reaction? So it's a electrophilic addition reaction. So why alkene has electrophilic addition reactions? So we can write the alkene molecule in the with the orbitals. So the carbon atoms in the double bond is sp2 hybridized, so it has 3 sp2 hybridized orbitals, and it has a one unhybridized p orbital. So in this double bond, the one is a sigma bond, the other one is a pi bond. Therefore, alkenes are electron-rich compounds. They have high electron density above and below the carbon-carbon atom plane. Therefore, any electrophiles can attack on these uh, 5 electrons. Okay, let's see the mechanism of this reaction. The first step of the mechanism is uh, the 5 electrons of the double bond is attack on the hydrogen atom. So why it's attack on the hydrogen atom? So this hydrogen chloride in this hydrogen chloride, chlorine is more electronegative than hydrogen. Therefore, the bond between hydrogen and chlorine has polarized. Therefore, we can write delta plus, delta minus. Therefore, this 5 electrons can attack on this positive center. And when you write the mechanism, make sure you have to draw the valence electrons of atoms. The chlorine has 6 lone pairs, so you have to show those lone pairs in the structure. Okay, so there is a two electrons shown that these 2 carbon atoms uh, 2 electrons shown this double bond carbon atom. So the one of the carbon atom take the electron from this carbon and it donate to the hydrogen and make a bond. uh, Therefore in the same time uh, when when the new bond making between this carbon and hydrogen, this bond is hit this bond the bond between hydrogen and chlorine is heterologically dissociate like this way. So what is the product it's forming? So it's K. So this one gain 1 hydrogen, therefore now this has 2 hydrogen, and there was a hydrogen here. So this carbon atom lose a 1 electron, therefore it's make a positive here, and it's make a carbocation, and in the same time it's forming the chloride. But make sure you have to show the lone pair electrons of chloride. It has a 4 lone pairs. So this is the first step of the uh, mechanism. Okay, now let's see the second step. So in the second step, one of the electron pair of the chlorine is attack on the positive center. So we can write this one attack on the positive center and it make a bond with the carbon. So what is the product form? So this is hydrogen, hydrogen. It has hydrogen and you bond with chlorine, and make sure so when the uh, one electron is donated to carbon, it loses one electron. When the chlorine donate one electron to the carbon, it loses one electron. Therefore, its negative charge become neutral. And this carbon gain a one electron. Therefore, it's become neutral. And chlorine has six, three more. It has three more lone pair electrons. So, and when you write the mechanism like this, always remember you have to draw the arrow from uh, negative to positive. Look here, the negative means the electrons to the positive center. Here this bond dissociates to the chlorine, and here also electrons to the positive. Okay, now let's see what are the transition state of these two steps. So let's write the transition state of this one. Let's denote I, and this one let's denote double I, the transition state. Let's draw the transition state. First one now. When you draw the transition state, you have to consider what bonds are formed and what bonds are broken. So if you see the structure here, the double bond is broken, and there is a new bond formed between carbon and hydrogen, and the bond between hydrogen and chlorine is broken. So let's draw the transition state. So it has a cyclic cycle, and this double bond breaks. It means at the beginning there's a double bond here, and in the product no double bond. Therefore, we write it in the dotted line. And at the beginning there is no bond between there is no bond between this carbon and hydrogen, but the product it has a new bond. Therefore, we have to write in the dot as a hydrogen. And at the beginning there's a bond between hydrogen and chlorine, but in the product it's broken. Therefore, we have to write write it in the dotted line. Chlorine. And in the at the beginning at the beginning there's a no charge on this carbon, but the product it has a positive charge here. And at the beginning there is no charge on the chlorine, but there's a negative charge here. Therefore, we have to put here delta plus, and here delta minus. And make sure when we write a transition state, we write it in the parentheses, square parentheses, and we denote the symbol like this, two plus signs. And let's draw the transition state of the second step. Transition state of the second step. So first draw the cyclohexyl ring. So here uh, here at the beginning there is no bond between this carbon and this chlorine, but the product there's a new bond. Therefore, you have to write the dotted line here, chlorine. And there's at the beginning there is a positive charge here, and the product there is no positive charge. Therefore, we have to write this one, this carbon, delta plus, and at the beginning there is a negative charge on chlorine, but the product there is no charge on the chlorine, therefore we denote it as a delta minus. And transition state we write inside the parentheses. So this is the answer for this problem.